Logarithmic functions. I'm just going to put log. Log functions and properties. Y equals log base b of x. So y is the logarithm of x with base b. It's the same thing as x equals b to the y. Let's just practice. Let me see if I write it like this. Base to the exponent equals the answer. Same as log base answer equals exponent. Same thing here. This is what I wrote. Base to the exponent equals answer. Log with a base b to the answer equals exponent. Okay, exponential form. Exponential form and then log form. Five to the minus 3 is when you have a negative exponent, it goes to the other side. So I really have 1 over 5 cubed, which is 5 times 5 times 5. Sorry. 1 over 24, 125. So log to the base answer equals exponent. How would I write that? Log to the base is the big number. That's how I remember it. The answer equals the exponent. Okay, 10 to the minus 4 is 1 over 10 to the 4th, which is minus is 4 decimal places, 1. So we log base 10, because that's what my big number is. Answer equals exponent. E to the 2. And E is on your calculator. It's like, I don't know, 2 point something, 3 point something. Kind of one of those pi numbers. And you calculate, if you do e to the second power, that's what you'll get. So log to the base, which is the big number, happens to be a letter this time. Log base e, answer equals exponent. Or squared. Log base, big number, answer equals exponent. Just get in practice writing exponential form, logarithmic form. 1/4, or sometimes you have a fraction, cubed equals 1/4 times 4 times 4, 64. Log base, big number, happens to be a fraction, that's okay. Answer equals x1. B to the y equals x. Log base, big number, happens to be a letter. Answer equals x1. Okay, let's really just practice in writing them back and forth, okay? Let's write it in exponential form. Given the log this time, how would I write it in the exponential form? Base to the exponent equals answer. Base to the exponent equals answer. Log base 10 of 100 equals 2. So base to the exponent equals answer. Base to the exponent equals answer. Base, exponent, answer. Log base 16 of 64 equals 3/2. Base to the exponent equals answer. Okay, we write in logarithmic form. 5 to the 4th equals 625. Log base, which is a big number, answer equals the exponent. E to the 5th equals, remember I said e's on my calculator or phone, whatever you young people are using these days. So log base is the big number, answer, all of that, equals exponent. Ten cubed equals 1,000. Logarithmic form is log Base is the big number. The answer was 1000 equals the exponent. Cube root of 64 equals 4. Oh, I write the log. This is really 64 to the 1/3 equals 4. So base is my big number. My answer equals the exponent. The base for the logarithmic functions are mostly tan and e. Common log, let me write this down nicely. Common logarithms have a base of 10. Common logs have a base of 10. So y equals log base 10 of x. Here we already had this. This is not helpful. You don't need a base, but it's a common log. It's kind of like how we didn't write 1x when we just had x. Same thing. If the base is 10, we don't need to write it. Natural logs have a base e. Base of e. So y equals log base e of x. And the same thing as y equals ln of x. I don't know why it's not nl for natural log, but I'm thinking it's French and it's log natural. But ln means that the base is e. Okay, so evaluate by rewriting in exponential form. Log base 2 of 8 equals x. So base to the exponent equals answer. Base to the exponent equals the answer. And this is the answer here, the big number when it's in log form. So 2 to what power equals 8? 2 times 2 times 2. So 2 to the 3rd power, or 2 cubed, equals 8. X equals 3. Log base 10 of 10,000 equals x. Base to the exponent equals answer. Base to the exponent equals the answer. How many zeros of that is 4? So the exponent has to be 4. Log base 4 of 2 equals x. So base to the exponent equals answer. Base to the exponent equals answer. Well, 4 times, and no exponent's going to give you, sorry, 2. that the square root of 4 is 2. So the square root of 4 equals 2. How can I write the square root of 4 in exponential form? I can write it as 4 to the 1/2 equals 2. So my x equals 1/2. My exponent is 1/2. 10 to the log base 10 of 10 equals x. This one's taking a while. So log base 10, the big number, log base to the answer equals our exponent, which is this whole thing. Our exponent was all log 10 of 10. Log base 10 of x equals 1. So 10 to the 1 power equals x. Base to the exponent equals answer. X equals 10. There's some laws here. Laws. It's not a lot of them, but they often look the same after a while. Log base b of two things, or two numbers, or two expressions is the same as log base b of the first one plus log base b of the second one. Kind of like exponents, when you multiply your exponents, you add them. Kind of like the same thing with logs. Log base b of m divided by n. When you divide exponents, what are you doing with them? You're subtracting. So now you're just subtracting the log base top minus log base bottom. This one's related. Log base b of a number to another exponent equals, it comes in front like a coefficient, like a regular number, times the log base b of the big number. Let's marinate on those while we go up a little bit. Okay, let's expand this one as much as possible. Like stretch it out, rewrite it, and do all that stuff as much as possible. Log base a of x squared times cube root of y over w cubed. Okay, so let's see. We'll take out the log part, because the log of a number divided by another number, or a term divided by another term, you will subtract them. So log base a of the x squared. I'm going to put y to the third instead of that square root business here. So this I just substituted for y to the 1/3. Minus log base A of the bottom. Equals, and now I'm going to split these, right? This, when I have two things multiplied, I'm adding them separately. So log base A of my x squared plus log base A of my y to the 1/3 minus log base A of w cubed. Now when I have this, when I have the base with a big number, my answer has an exponent with it. This comes in front. Like an exponent. So I have this rule, and now I'm doing this rule to the same problem. So the two will come in front, and I'll have log base A of x plus this 1/3 is going to come in front. 1/3 log base A of y minus this exponent is going to come in front. 3 times log base A of w. And they all have a different something, right? So I can't add them to each other. This one has an x, this one has a y, this one has a w. So this unfortunate lengthy business is our answer when we expanded it. Log base 5 of 8.21. Yeah. So I have log of 8.21 over log of 5. And this you can use in a calculator as a calculator function. Then you can just do log 8.21, and it's going to give you a series of decimals. They'll both be decimals, by the way. If you had a log and it was a whole number, then you did something wrong. Unless it was a natural log. Log of 5 is 0.69897. And then we divide those two. Point, well, that's 1.3081. I usually go to 4 decimal places for when I'm doing the logs. Okay, express as one logarithm. 1/3 log base A of x squared minus 1. You knew it was coming. We can have these things inside the logs too. How awesome is that? Log base A of x plus 4 times the log base A of 10. So when you see a number in front of the log, you know that this situation had to happen. That my answer part had an exponent in it. So let's start with the first one. 1/3 will come down in front of the whole thing. It's already there in front. So I'm going to write it in log form. So log base A of this, and I'll put the exponent back there, minus log base A of x plus log base A of 10 to the 4th. I put the 4 back up there. Log base A of the cube root of x squared minus 1. X squared minus 1. Minus log base A of x plus log base A of 10 to the 4th is 1 with 4 zeros. Log base A of x squared minus 1 to the 1/3 minus log base A of 10,000 x because this I had the same log base A with this. So then these, if these were added, that means they had to be multiplied. They had to be multiplied in the beginning. I have the same base, different answers, then they have to be multiplied in the beginning. So that gives me now, and now I have the same base with same base here with 2 different terms and a minus sign means they had to be divided original. So log base A of the top one, I'll write it back like this, over the bottom. That's ugly. I've never put that on a test for you. I'm going to graph one to show you what exponential growth looks like. Sketch the graph of y equals log base 2 of x, which is the same as base to the answer equal also the exponent equal to answer. Base to the exponent equal. So I'll do my table of values from way back when, way back when. And draw the big one. And 0 minus 2 minus 1 0 1, 2. Okay, if x is -2, if my answer is -2, 67. This is my y and my x. It's kind of hard to do it backwards, but my answer part is now this. So 2 to the -2, 2 to the -2 equals 1 over 2 squared equals 1/4. That's what my x is. Two to the -1 equals 1 over 2 to the 1 equals 1 over 2. Two to the 0, anything to the 0 power equals 1. Two to the 1 equals itself 2. And then 2 squared equals 4. So these are my points. 1/4, comma, -2. So 1/4 here, negative -1, sorry, 1/2 and -1, 1/2 and -1, 0, 1, 0. Oh, weird to make it go 1, 0. 2, 1, 2, 1. 4, 2. Now I connect these. And it doesn't look like a linear one, it doesn't look like the squared ones. They have their own thing going on. And we got something like that. Okay. Exponential growth or graphing.